I released a video recently with code to draw high and low trend lines on a chart, and they were based on a tangential formula. I have the lines drawn on a chart here. This is the pound US 1 hour chart, and you can see that the upper line here is tangential to the high points. It's just touching the two highest points, and the low is just touching the two lowest points for the interval that I've selected. This is a good indicator for a tangential type trend. But as you can see here, it's indicating that the high prices are diverging from the low prices, and it's mainly due to these high outliers, these spikes in the pricing. So it's not necessarily the best indicator to use. So today I'm going to be showing a different technique for finding a trend line for the high and the low of a segment. And it will use similar techniques. I'll be creating a class, and that class will hold a point and a slope. So that will effectively generate the straight line formula that you can use to get the value of that trend line at any point in the chart. But this technique will draw lines that will actually allow the line to intersect with some of the candles where it needs to, because it will be trying to find a best fit of the upper and lower prices, or the high and low prices. And I'll be using linear regression for this. Now you might already know in MetaTrader 4 and 5, there is already a linear regression tool. Let me just insert that here. It's under Objects, Channels, Regression Channel. If I draw that between the same points on this chart, and it doesn't matter where my cursor is vertically, you can see as I move it up and down, the line still is drawn in the same place. This line will draw a central linear regression line, and then equidistant high and low. Now, according to the documentation, this line is drawn such that the high and the low are distant by the greatest deviation of a close price from the central line. Although when I look at this, I can see that at this point, for example, I have a closing price here, and that distance from it, you can clearly see the close is outside the upper line. So what actually appears to be happening is that the opening price of the following candle here is setting the distance from the linear regression line. I'm not sure if that's deliberate or a mistake, but they do seem to be using the opening price of the following candle rather than the closing price of this candle to set the distance. There is a second indicator, which I will put on the chart now, which also uses linear regression, and that is the standard deviation channel. If I draw that between the same two candles, I've used a different color, but you can see the central line is overlaying the existing regression line. So the formula for the central line is the same, but the two upper and lower lines are in a different place. And that's because by default, the standard deviation channel sets the upper and lower lines to be one standard deviation away from the central line, and that's a standard deviation of the close prices. You can go into the properties of the channel here under the parameters, and you can see there is deviations here. So the default is 1. If I set that to 2 deviations, then it moves the upper and lower lines further away. Nothing wrong with those indicators, except the possibility that they're using the opening price rather than closing price. But what I want is a regression channel based on the high prices and the low prices, because I don't want parallel lines. I want to see if prices are converging or diverging. And both of these channels that are built into MetaTrader don't give me an option to choose high or low prices. So just like the earlier video where I showed how to draw a trend line based on the high and the low prices, I'm going to show now how to draw a trend line using linear regression based on the high and low prices. Now I've opened the MQL5 editor here. I've got the trendhighlow.mq5 and the trendhighlow.mq4. These are from the last video, and I'll put a link in the description and on the screen so you can see that video, because I'm going to be using the code from that in this video. What I've done here previously, I set up a class called I've set up an include file called trendhighlow that includes a class cTrendHighLow. Because I'm now going to be creating a linear regression high and low, I'm going to be creating those as a version 2. So I've moved this trend high low file into a V1 folder under trend lines. and then I'm going to be copying this into the version 2 where I will create a base class, and then I can inherit from that base class for the linear regression class. And so all I've done in the original trend high-low MQ5 and MQ4, I've added this /v1 into the path, and these still compile. So now I'm in the version 2 folder. I have copied the trend high-low file directly from v1, and I've created a linear trend base file, and I've simply copied all of the code from trend high-low into that to begin with. In the linear trend base file, first thing I'm going to do is replace the name, which is no longer trend high-low. That's going to be linear trend base. And I'm calling this linear trend base because these are all straight line formula. They all consist of a slope and a point. So all of the properties remain the same. I'm still including object.mqh because this base class will inherit from object. And this is also where I'm declaring these structures, the S-trend point and the S-trend. You can get more detail on these if you watch the earlier video, but the trend basically is the base point and a slope, and the base point has the bar number and the price, and I've thrown in the time, although so far I haven't had any need for that. Class name C linear trend base inherits from C object. These values, and remember I've copied this directly from trend high-low, these are all common information. So I'm going to need a symbol and a time frame in all of these trend lines, and they all have a start bar number and a length. And then they will all contain an upper trend and a lower trend. So I'm calculating both trends at the same time. And this protected function value at. Now I am going to be inheriting from this. I'm going to make this function virtual. I know that in the classes that I'm going to be creating today, I don't need this to be a virtual function. The function here in the base class will do everything I need. So if you want to reduce processor load just a little bit, you might want to remove this virtual until you need it, but I've just put it in there for now. No changes in the constructor and destructor other than the name change here. All of these functions, update, update lower, and update upper, are going to be common in all of the classes, and I am going to make all of these virtual. Now the same with the upper value at and lower value at functions, because these will simply return the price value at a given bar number or a time. But just as with this value at, I'm making these virtual so that they can be inherited easily, but so far I've had no need to do that, and the functions that will be in this base class will be used. The start functions, the int and the void, are used to modify the start value once the class has been created. So once you pass it in with this constructor, you can change it later with this start value, and you can get that value back with this start function, and the same with the length. I have no need at the moment to make those virtual, and I haven't made them virtual here. Now in the constructor, most of this remains the same. I'm still capturing the symbol and the time frame from the chart, and I'm setting the start and length based on the arguments passed into the constructor. I am going to remove this update. In the base class, I don't want to call an update when the class is first instantiated, because the update will be calling update lower and update upper, and these will be changed in the child classes simply because the method of calculating these is going to be different. Now, I have an earlier video, which I'll also leave a link to and on screen, where I explain why you shouldn't be calling a virtual function from the constructor of a parent class, because it simply will not work. So I've taken that update statement out of this function. Still nothing in the destructor. The update function simply calls the update lower and the update upper, so I'm leaving that function here. Now this update lower function came from the original trend high-low, and I don't want to have a function like that built in. I actually don't want to do anything in the base class from calling update lower and update upper, so I'm going to remove this. So I've removed those two update lower and update upper functions, and what I'm going to do then here in the update lower, I want to force these to be virtual. So I'm just inserting this equals 0, and that will force the child classes to implement these. Now the upper value at based on index and time, and the same for lower value at, no need to change these. They are nice generic functions, and I can continue to use the functions from the base class. and the value at is a function that's called by these upper and lower value at. So that's also something I can just leave in the base class. So that base class is complete now. Let me just run a quick compile check on that. So while this doesn't actually compile because it's an MQH, it does a syntax check, and that shows me I have no errors. Now I want the trend high-low to inherit from that class. So here in the trend high-low, I'm no longer including object. What I want to do is include linear trend base. So this is with quotation marks now because I'm not looking at an absolute location. I'm looking at linear trend base in the same folder as trend high-low. So quotation marks linear trend base.mqh. The structures are already defined in the base class, so I can just remove those. And this now inherits from C linear trend base instead of C object. These values for symbol, time frame, start and length, and the two trend values for up and lower are no longer needed. I'm going to be using value at from the parent class, so I can also remove that. I still need a constructor, trend high-low and destructor, but when I get to the implementation of these, they will call on the parent class. But the arguments here are the same, start and length. I'm going to remove this update because the update function in the parent class will work for me. But I need the update lower and update upper because that's where the actual calculation based on the original tangential trend high and low are. Then the value at functions, I can remove all of those, and I don't need these property statements because they're also in the parent class. Now the constructor here, I'm simply going to call the parent class. So this syntax colon C linear trend base will call the parent class, passing the same two arguments. And that takes care of assigning the symbol, time frame, start and length. And then I removed update from the parent class, so I'm leaving it here because in this class is where I actually have the update functions that I need. I've removed update from this class, so I can remove that. But I do need update lower, which I can leave there, and update upper, which I can also leave. And then the rest of these functions are all in the parent class, and I don't need to modify them in this class. So that has simplified the trend high-low class, and all it now has are functions to calculate the upper trend and the lower trend. And everything else is coming from the parent class. Let me do a syntax compile on that, and that also works. But now what I want to do is create the linear regression class. So I have a file here already for trend linear regression. I'll open that, copy this code from trend high-low, and then make the changes I need for linear regression. All right, I've opened the trend linear regression file. I've copied everything from trend high-low. First thing, I'll just change this. The property statements are the same. I'm still including the linear trend base because this is still inheriting from that. Class C trend linear regression inherits public from C linear trend base. Same constructor, start and length. And I still have just the update lower and the update upper functions here because they will perform the calculations for me. Constructor does the same thing, calls the parent class, start and length, and then calls the update function. And the update function in turn will call C linear regression update lower and update upper. But the code in these update lower and update upper functions is very different to the trend high-low. So I've removed all of the code inside the update lower and update upper, and I'm going to be writing another function to perform the calculation for linear regression. So each of these will call with the appropriate values. So in the update lower, I'm going to be calling this new function, which we'll write in a moment, update linear regression, mode low, because I'm going to be looking at the low prices, and M lower trend, if you remember from the parent class, M lower trend is of type S trend, so that's actually storing the trend for the lower trend line. And I do the same in the update upper, but in this case I'm calling update linear regression with mode high and upper trend. So now to create this update linear regression function, first I need to declare it in the class here. I'm going to put it in protected just in case one day I want to inherit from this. It's void because I'm not returning anything from the function. I'm actually setting the values of this trend variable. So the two arguments to that are the price mode and a variable of type S trend, and that's a pointer to a variable. So because I'm going to be updating the values in trend directly. So here's the beginning of my update linear regression function. Now linear regression is a well-defined formula. I'm not going to go through all the math of how this works, but I will show you the code that I'm using and try to explain how the code does what it needs to do. Now to calculate linear regression, I need to actually do a loop through each of the values and calculate something on each bar. And the bar numbers that I'm using here are going to be the offset from the start bar. So I need to declare some values that I can update as I'm going through that loop. There's the sum y, which is the sum of the y values, and in this case y is going to be the prices and x will be the bar number. So sum of the prices will be calculated, and then sum xy, which is the sum of the products of the bar number multiplied by the price at that bar. And then price is just a working variable that I'm using. So a standard loop here for int I equals 0, while I is less than length, I++, so I'm counting upwards, and remember this is counting from right to left, beginning with the start bar. So the price equals, and then depending on the mode, whether it's mode high or mode low. Now this is inside my class, so there can only be mode high or mode low, so I don't need to test every possibility, just high or not high. So if the price mode is mode high, then I'm picking up the high price using I high, symbol, time frame, I plus the start bar, the M start. And if it's not mode high, then I'm using the same thing for I low, M symbol, time frame, and I plus M start. So that gives me either the high or the low price depending on the mode that I'm using. So then sum y, which is the total of the prices, just sum y plus equals price, and sum xy plus equals I multiplied by price. So this is the bar offset multiplied by the price. Again, I'm not trying to explain the math, this is just what needs to be done to calculate the linear regression. So at the end of this loop, I have the total of the price of every bar in that segment and the total of the price multiplied by the bar offset number. Now I need some standard formulae. The average X value, or the average bar number, and again this is the offset bar, so it's not the absolute bar number, this is the bar number relative to the start bar. So the average is just length minus 1 multiplied by 0.5, standard formula. And the sum is the length multiplied by the average. I also need to calculate the sum of the squares of those X values. And this is a standard formula again. It's the length minus 1 multiplied by the length multiplied by 2 times length minus 1, all divided by 6. Again, don't worry about the math, that's just the formula. And then I want a divisor that I'm going to be using in the following calculations, and that's the square of sum x, and I'm just using sum x multiplied by sum x rather than the mathpow function, minus the length multiplied by sum x squared. Once I have that, I can calculate the two essential things for a line, which is an intercept and a slope. Given those two values, I can always calculate any point on the line. So the intercept, assuming the divisor is not equal to 0, is sum x multiplied by sum xy, these values we've calculated above, sum x and sum xy, minus sum y multiplied by sum x squared, so sum y multiplied by sum x squared, all of that divided by the divisor from here. If the divisor is 0, then I'm just going to return 0 for intercept because I don't want to get a divide by 0 error. Remember, I'm dividing by divisor. Slope, same condition. If divisor is not equal to 0, then it's length multiplied by sum xy minus sum x multiplied by sum y divided by the divisor. So that gives me an intercept, which is going to be at the first bar of the segment, and the slope. And that gives me everything for the linear regression formula. I can just store those now in the trend. So trend.slope equals the slope directly from here. Trend base price equals the intercept. So that gives me the price at the first bar. And that's why I'm setting trend base bar equals the start bar number, which is what we passed into the constructor for the class. And then I'm just calculating the time using itime for the symbol, the time frame, and the start bar. And I'm storing that in trend base time. So that gives me the trend based on whether I've passed in mode high or mode low. And so that's everything for the update upper and the update lower functions. Let me do a compile, make sure I haven't made a typing error there. And that's correct. So now, just as last time, I'm going to create a script that calls this and will then draw the upper and lower trend lines on screen based on this. But also remember, this is a class that simply gives you a value. By calling, let me go to the base class. By calling upper value at and lower value at, you can get a price value based on this trend at any point in your chart. It doesn't have to be within the segment that you specified. So here is trend linear regression.mq5. There is also an mq4 here. I've put them in orchard trend lines linear regression. The mq4 version is identical to the mq5 version. First thing, include orchard trend lines v2. Remember, I've put the linear regression and its parent in this v2 folder. So v2 trend linear regression.mqh. Two inputs, a start bar and a length, which I'm defaulting to bar number 1 for a length of 50 bars. Then I'm declaring C trend linear regression pointer, and I'm calling the variable trend. So first thing is to initialize trend. That's a new C trend linear regression start and length. And I'm just doing a quick calculation of an end bar here because I'm going to be using that later. It's just easier to do it once. And the end bar number is the start plus the length minus 1, because that's the number of the bar, not the distance away. So then I call trend.update, and that will perform the calculation based on this start and length. And then I'm calling a draw trend. That's a function I've got down here, just so I don't have to repeat too much code. And that's going to be passing in the name of the line that I want to draw, the start point, which is trend.upper value at end bar, and the end point, which is trend.low upper value at 0. So although my start is at bar number 1, I'm going to be drawing the trend line all the way to bar number 0. And then I'm doing the same for lower. Draw trend, lower line name, and then the start position, lower value at end bar and lower value at 0. And then I just delete trend to clean up when I'm finished. And the draw trend simply creates a trend name, which is name plus trend. So that's creating a name of the object on screen. Recalculating the end bar here, start plus length minus 1. I'm deleting that line in case it already exists on the screen, and then I'm creating it. On chart number 0, trend name, it's a trend line, so obj underscore trend, subchart 0, and then the two values that I need are the time and price for the first point and the time and price for the second point. So the prices are coming through in the arguments here, value 1 and value 2, and the first point is going to be the end bar. That's why I've recalculated it here, and the second point is bar number 0. So I'm using the itime function to get the times for those. And then I'm just changing the color to green and the width to 2 so it's easier to see on the screen. All right, now let's go to MetaTrader 5 and I'll call this up. Now I'm back on MetaTrader 5 here. I've already loaded the trend high-low example with a start bar of 15 and a length of 40. And so you can see I'm getting this trend just touching the two upper points and just touching the two lower points. To show the difference now, I'm going to load the trend linear regression. Also starting at bar 15 and for a length of 40. So you can see a very different channel here, which depending on your needs may be more representative of the prices that you're looking at. And these two lines are not exactly parallel, but they are close to it, which indicates that the price is actually trending upwards rather than in a narrowing channel. but I still find these are too close together. I would like to see this line a little higher, and I would like to see this line a little lower. So what I want to do is introduce into the code an offset of this, and I'm going to be introducing that based on the standard deviation of the linear regression line. So now I'm back in the code, and this is the trend linear regression class file. I'm going to add a variable here where I'm going to be storing the deviations. And so this will offset the line by the number of standard deviations specified in this. I also then want to modify the constructor so that you can pass in those number of deviations. And I've just set the default value here to 2. There's no change in the update lower and update upper because all of these values are member variables, but this mDeviations doesn't exist in the parent class, and I also want to set properties so that you can update or read this after you've initiated the class. So I've set up 2 functions here. Double deviations will return the value of the mDeviations that's stored in the class, and void deviations double value will update that. So it sets mDeviations equal to value and then calls the update function. So that lets you change or read the number of deviations after you've initiated the class. In the constructor, I just need to add the extra argument for the number of deviations. Let me wrap that around. And because it's not one of the arguments passed to the base class, start and length, I need to assign deviations here. So just a simple assignment, mDeviations equals deviations. I don't want to call these functions at this point. And then update. No change to the update lower and update upper functions, but the update linear regression will change. In order to calculate standard deviation, I need to capture additional information during this loop. So I'm going to declare an array that I can use to capture those values. So I just want to capture each price as I go through. So I've declared an array double prices, and then I'm resizing that to be the length. And then to capture these values during this loop, I just have this statement, prices I equals price. So at the end of this loop, as well as some y and some xy, I'll also have an array of each of the prices in that segment. Everything down as far as slope is fine. After that, I'm going to calculate the standard deviation. First, I need the average of the y values, and that's just the sum of the y values divided by the length. And then I need another loop where I'm going to calculate the sum of the differences squared between the y values and the average y. So I create this sum diff squared and initialize that to 0. Now another loop for int I equals 0 while I is less than length, I++. I'm getting the price from the array that I built up earlier. That just saves me having to do this statement again, and that's why I captured that array earlier. So now I can simply look at this array instead of doing that calculation. It just saves a little bit of processor time. Price equals prices I, and sum diff squared plus equals the price minus the average, so the difference from the average, multiplied by price minus the average. So I'm squaring the difference between the average price and the price on that bar. Now the variance, assuming length is greater than 1, is the sum of the difference squared, this that we've just calculated in the loop, divided by length minus 1. And if length is less than or equal to 1, then just 0, because you can't calculate the variance then. And the standard deviation is then just the square root of the variance. So once I have that standard deviation, I'm going to modify the intercept value. So if it's a mode high, intercept plus equals deviation by the multiplier for deviations. And if the price mode is mode low, then it's just intercept minus standard deviation by number of deviations. Once I've done that, I can still just store intercept here in the price, because all I've done is shift that intercept up or down depending whether I'm looking at the high or the low. And I think that's everything. Let me do a compile here for syntax check. That worked. So now to use that in the script, I'm going to add another input. So input double input deviations equals 1. That's my default. I need to change the constructor now to pass those number of deviations in. And that's everything. And go back to MetaTrader, trend linear regression, and that was 15 and 40. I'm leaving a 1 deviation shift. Now you can see the lines have moved out. So it still does intersect with these outliers, these spikes in the pricing, where the tangential line will not intersect with any candles. But this is a best fit line following the linear regression of the high prices in this segment, and this is the best fit line following the linear regression of the low prices in this segment. They appear to be parallel because that segment just happens to be reasonably straight, but they are not. They actually do have different slopes. Let me scroll this chart back a little. I'll see if I can find a place where they look quite different. So here I've scrolled the same chart back a little, and I've set these up on a different beginning bar. It's still 40 length, but it's a different start bar. I think it's bar number 90 at the moment. And you can see that I actually do have lines that are not parallel, the upper line sloping down and the lower line sloping up. And again, you can see there are prices here that have gone outside the line, both upper and lower. So this is not the tangential line. I've just moved the tangential line on here, and you can see it's just touching the low points inside the range and the high points inside the range. So it's giving a much more exaggerated view. And just to show, the MQ4 file for that script is identical. All of the statements here are the same as they are for MQ5. The only difference here is that I've changed the file name in the comment. And all of these MQH files are identical for MQ4 and MQ5. So that is a different approach to a trend line on the high and low prices. The linear regression formula is the same as the formula that MetaTrader uses, but where MetaTrader only calculates linear regression on closing prices, this will allow you to calculate on the high and the low prices. And it all comes down to the formula here in this update linear regression function. So I hope this is useful to you. If it is, then please click the like button. And if you want to see more of our videos, click subscribe and click the bell icon to be notified when we release new videos. Thank you for watching.